Hi all, in this lesson we're going to be solving exponential and logarithmic equations. So we're going to start by first solving exponential equations. Alright, so what are the strategies that we could use to do so? In a previous video we saw that we can solve this equation right here by getting the same base, and then once we get the same base, set the exponents equal to each other. For something as basic as this, I don't think I'd go through all that work. I would just notice that x could be 2 or is 2, and that would be my answer and I'd be done. I'd just write down 2 and box it and be done. But when the problems again get more complicated, what's the strategy that we could use to help us get the answer? Well, here's one strategy. Strategy 1. Let's get the same base so we can set the exponents equal. Well, notice that 16 can be rewritten as a power of 2. It's 4 squared. Once the bases are the same, drop those out. My answer is x equals 2. So if you have to show the work that leads to your answer, that's probably the quickest way. All right, not to confuse you, but I want to look at another strategy that can get us an answer of 2 as well that we might have to use in a later problem. Okay, what's something else that we should be able to use to get an answer of 2? All right, so strategy 2. Let's go back to the original problem. All right, some students don't like to get the same base because they struggle with finding powers here without a calculator. Some students don't mind doing this method though. Let's change it to a log. All right, it's in exponential form. To change it to a log, we start with the exponent because x is equal to a log. So x equals log base 4, based on the exponential, based on the log of 16. If you have a calculator, go to your calculator. Okay, the shortcut key is alpha window, option 5, dump everything in, get an answer. You could do the change of base. You could do log of 16 divided by log of 4, but why do that when we have that built-in option on our calculator? The change of base was really used previous to all the new operating systems where they have that shortcut key for log of any base. Used to be calculators didn't have the alpha window key, and you'd have to do the change of base to get an answer. You'd have to do log of 16 divided by log of 4. But with technology, we don't have to do that anymore. Anyway, alpha window, option 5, dump everything in, answers 2. So do you want to get the same bases, set the exponents equal, or do you want to change the exponential to a log equation and use your calculator? Your call. Problem 2, how do I solve this exponential? All right, 2 strategies again, like in the previous problem. Strategy 1, get the same bases. Well, that would require my taking 625 out of the denominator, but before I did, okay, you probably don't know this one, but 625 is the result of taking 5 and raising it to the 4th power. Okay, to get the same bases, I've got to bring 5 out of the denominator, but if I do that, I adjust the exponent and make it negative. Same bases, yep, x equals -4. That makes sense. If my exponent is negative, then I'm going to have a number in the denominator. 4th power and 5 gives 625. A lot of students don't like this strategy because you have to really have a good handle on your powers without a calculator. All right, what's the second strategy? Well, change it to a log equation. Use your calculator. Changing it to a log equation, start with the exponent. X equals log base 5 of 1 over 625. Don't do a change of base on this. Go to alpha window, option 5. Just be careful and with your fraction here and use the fraction template, alpha y equals. Your answer is -4. if you're going with the log option, I might suggest just stopping the video and making sure that you're able to get an answer of -4 from those calculator keystrokes. All right, let's continue solving exponential equations. All right, we have an exponential equation. We have to figure out what the exponent is to take 1/8 to that power and get a 64. Alrighty, without a calculator, because this is certainly one that could be done without a calculator. Okay, I wouldn't change it to a log form. I would use strategy 1 if I had to do this without a calculator. But for this problem, we'll look at both strategies again. All right, strategy 1 says let's get the same base. I know 64 is 8 squared, so I might use the base 8. So for me, I'm going to rewrite 1/8 as 8 to the -1. So 8 to the -1 is 1/8. Don't forget about your x. Come over here, rewrite 64 as 8 squared. So we're close to having the same base, but we need to take care of this little situation right here. Properties of exponents from Algebra 1 say that I can keep 8 and multiply these two together and get -x. Bring down 8 squared, same bases. Let's put the exponents equal to each other. -x equals, -x equals +2. I got a step ahead. Divide both sides by -1, so then I'm going to get an answer of -2. Just kind of make sense of that answer. If you were to have an exponent of -2, okay, what that means with a -2 is to make it a +2 exponent, I would have to reciprocate getting 8 here, and 8 to the +2 would be 64. All right, second strategy would be if you don't like working with bases and you had a calculator, put it in log form. So x equals log of the base of 1/8 of 64. Again, go straight to your calculator, alpha window, option 5, put everything in correctly, watch your keystrokes. The answer would return to you as -2. I'm not saying you have to do both strategies. You just choose the one that you like the best. I wanted to present you with both options, though. Okay, let's look at number 4. Okay, well, taking a look at number 4, strategy 1 in the previous 3 examples won't work. I'm not going to get the same bases. I can't rewrite 14 as a base of e, so that option's out. So I have to go with strategy 2. All right, I got to solve for x. I want to get x out of the exponent position. That would require my changing this to a log form. All right, so x equals log base e of 14. Some of you guys might have noticed that you could bring in ln, and that's fine. Okay, you can go straight to your calculator. Alpha window, option 5. You know E is above the on key, a few keys above. Otherwise, identify that log base E can be rewritten in the alternate form, natural log of 14. So log base E is actually the natural log. Personally, this is what I would do. I'd go to my calculator, hit the ln key, 14. Let's round to 5 decimal places. All right, pay attention to the structure of problem number 5. This is 6 times 10 raised to the x. The x is only on 10. It would be wrong to multiply the 6 into the 10 when the 10 already has an exponent of x. It would be wrong to say this is equivalent to 60 raised to the x power. All right, so there's one additional step that's being added on to this problem that we're going to have to address. I need to isolate 10 to the x, so let's divide both sides by 6. Let's get rid of that 6 first. Then I just have 10 to the x equals. The calculations on this results in 36. All right, well, what exponent do I need on 10 to get 36? Well, I can't get the same bases. 10 and 36 don't rewrite as powers with the same base. So strategy 1 is out. I need to change this to a log form. X equals log base 10 of 36. Yeah, I'm not going to do alpha window on this one because log base 10 is just simply the common log. I'm just going to go to the log key on my calculator and calculate this answer. But it should give you the same thing if you wanted to use alpha window. All right, you might not see it, but I can apply both strategies to number 6. All right, so one strategy is to equate the bases, get the bases the same, to drop them out to set the exponents equal to each other. Honestly, that's going to be the most difficult strategy. Changing it to log form is easier since we have a calculator and a fraction template. We'll save the easier strategy for last. Let's do the more complicated one where we try and get the same basis. Try and get a base of 2/3 or something of that manner. All right, so I'm going to bring down 2/3 of x. Some of you guys that are good with your numbers, you can see 81 as a power of 3. Well, 3 squared is 9, so 3 to the 4th must be 2 9s multiplied together. So 3 to the 4th is 81. 16 can be rewritten as 2 to the 4th power. Okay, if these exponents are the same, I can do a rewrite. I'll pull the 4 off each of them, the power, and put it on the outside of the fraction. A lot of you guys aren't going to see that, don't want to mess with it. From the very beginning, you're just going to change it to log form. Well, that's wonderful. All right, notice my bases are just reciprocals of each other. So I either need to change 2/3 to 3/2, making this exponent negative, or I need to change 3/2 to 2/3 by flipping it and making the 4 negative. I need a 2/3 base, so I'm going to reciprocate, but the result of doing that is make the adjustment on the exponent to -4. Same bases, they fall out, x equals -4. Meant to write down strategy 1. So strategy 2. Change to log form. Go to the calculator, alpha window, option 5. You're done. You need to know both strategies because if this problem appears on a no calculator test or homework, you need to be able to find this answer with no calculator. If this problem appears on a calculator test, I probably would change it to log form since I have that shortcut key. So if you tend to kind of check out when I'm going through this strategy, you might want to check back in because this would be a problem that would appear on a no calculator part of an exam. All right, continuing to solve exponential equations, let's look at example 7. All right, so no calculator. If this appears as a no calculator question, then that tells me that changing it to log form is not going to help because I don't have a calculator. So I need to, in my brain, I'm going, okay, I got to get the same exponent. All right. Well, 2 is as small as it's going to go, so I got to come over here and I have to be thinking about what is 256? Is that a power of 2? 2 raised to what power is 256? And I can come over here to the side. I know 2 cubed is 8. So 2 to the 4th is 8 times 2. 2 to the 5th is 32. 2 to the 6th, keep doubling, is 64. 2 to the 7th is 128. So 2 to the 8th is a double on 128, and that produces 256. No calculator, that's a strategy you'd go through. Same basis, set the exponents equal. Just subtract a 3. The exponent would have to be 5, or at least x would have to be 5, so the exponent is 8 on 2 to give me 256. All right, quickly looking at strategy 2. If you got a calculator, change it to log form. So that means take the entire exponent equals log base 2 of 256. All right, to solve this equation, you have a calculator. Bring down x plus 3, go to alpha window, option 5. The answer returns as an 8 for this expression. Subtract the 3. The result is the same. The answer is 5. All right, that wraps up solving exponential equations. We need to continue and solve log equations, but that'll be in the next video.